All right, let's look at the derivative of inverse hyperbolic tangent. So the derivative of inverse hyperbolic tangent of x is 1 over 1 minus x squared. All right, let's see if we can prove this. All right, so first I'm going to let y equals inverse hyperbolic tangent of x. All right, so since we don't know how to deal with the inverse hyperbolic tangent function, I'm going to apply hyperbolic tangent to both sides of the equation. So you end up with, right, so if you apply hyperbolic tangent to y, you get the hyperbolic tangent of y, obviously. And then here, if you apply hyperbolic tangent to inverse of hyperbolic tangent of x, you're left with x because it's an inverse property. All right, so we have that. Now we know how to take the derivatives. So I'm going to take the derivative of both sides of the equation with respect to x. Right? So remember that a derivative of a hyperbolic tangent is hyperbolic secant squared. But since we're taking a derivative with respect to x, we have to do a chain rule, so multiply by dy over dx, which is actually exactly what we're looking for. And then derivative on the right hand side is going to be 1. Derivative of x with respect to x is 1. Right? So since what we're looking for is dy over dx, I'm going to divide both sides by hyperbolic secant squared of y. Right? Then you will end up getting this right here. Right, so dy over dx is going to be 1 over hyperbolic secant squared of y. Right? Then we can use the identity here. Hyperbolic secant squared of x is equal to 1 minus hyperbolic tangent squared. So we can replace this by 1 minus hyperbolic tangent squared of y. So let's go ahead and do that. So we're going to get something like this. All right, the good news is we know exactly hyperbolic tangent of y is. Hyperbolic tangent of y is actually x. So we can replace this by x. Then you will get what we wanted to get. Right? So this comes out to be 1 over 1 minus x squared. Right? That's exactly what we wanted to get. Right? That's it. I hope that this was clear.